So let's finish this chapter off with a bit of modeling. So we have a boat which has a position vector of 2i plus j and a buoy which has a position vector of 6i minus 4j relative fixed origin O. Find the distance of the boat from the buoy. Right, first things first, as with vectors, if they don't give you a diagram, it's always best to try and sketch your own diagram just to visualize it a bit better. Right, so we have the origin here. The boat is 2i plus j, so here, so roughly here, I'm going to label it with b. And the buoy has a 6i position vector minus 4j, so roughly here. And I'm going to label that as c, okay? Right, so they're asking us the distance of the boat from the buoy, so we need to find the vector, or the direction vector b to c, and then to find distance, we just find the magnitude of that, right? So we need to find b to c, which is just equal to c minus b, right? And c is 6 minus 4 minus b, which is 2, 1, which will give us 4 minus 5. And the magnitude of that would be the distance. So it's going to be equal to the square root of 4 squared plus minus 5 squared, which is equal to the square root of 41, in this case, kilometers. Okay, find the bearing of the boat from the buoy. So the bearing is always an angle relative to the north, right? So the bearing of the boat from the buoy, which means that from here, we're trying to find this angle here, right? So in order to do that, we need to find this angle, and we can just call this alpha and just do 360 minus alpha to find the bearing. So I can draw a right angle triangle like this, okay? Because I know the y and x value. So this y value here was the difference here, which is 5, and this was 4, right? So therefore, I can say that tan theta, tan alpha in this case, is equal to 4 over 5, meaning that alpha is going to be 38.7 degrees. And so therefore, the bearing will be 360 minus 38.7, which is 321.3. But remember, bearing is always a 3-digit number with it being an integer, so there's no decimal place. The bearing will be just 321, like this. So as you can see, with the diagram, it's much more easier to see what they're asking us to find, right? So the boat travels with constant velocity 8i minus 10j. Verify that the boat is traveling directly towards the buoy. So the velocity is 8i minus 10j. And the way we can show is that traveling directly towards it, then we can see using the two vectors being parallel. So we found earlier that b to c was equal to 4i minus 5j. And this I can rewrite as 2 times 4i minus 5j. And you can see that these two vectors here are parallel to each other, which means they're traveling in the same direction. Right. D. Find the speed of the boat. Well, the speed is actually just the magnitude of the velocity, right? So we just have to find the velocity, magnitude of the velocity, which is square root of 8 squared plus minus 10 squared. So we get root 64 plus 100. So the speed would be the root of 164 kilometers per hour. And finally, work out how long it takes the boat to reach the buoy. So we're looking for time. Luckily, we know that speed is equal to distance over time. And we worked out the distance in part A, which was root 41. And we know the speed over time is speed, which is the 164, root 164. So time is just equal to the root of 41 over the root of 164, which comes up to 0.5. And it's in hours, right? So 0.5 hours, which is the same thing as 30 minutes. Okay, so as long as this is just using vectors for modeling, so in like a more real-life situation, but the concepts are still the same, like finding angles, finding distances, and comparing whether they are parallel or not.